Hello, Trig. I am not here, but this class still needs to march on, so I thought I would record some, hopefully a little bit of review notes for you to go over and then a stamp to work on for something to do today. Hopefully you brought your headphones and we're not hearing my voice echo around as everyone's listening to it. But without further ado, we're in functions. We learned about functions yesterday, f of x and g of x and inputs and outputs and the vertical line test. And hopefully it was review and stuff is starting to click again and similar today. So let's go ahead and take some notes. If you have notes, please get them out and write some things down, see what you remember, and see what you need to focus on and kind of remind yourself about. So what we're going to focus on today are operations with functions. We have these functions, but we can do things with them. Obviously, we can add, subtract, multiply, divide. There are other operations that we can do with these functions as well, and we'll cover those in a second. But let's just do a quick recap and practice a few of these. You may have to hit pause for a second. But here are a couple functions, f of x and g of x. They both happen to be quadratic functions, right? This one, x squared, x squared. I would like you to add them, subtract them, divide them, and multiply them. So here is the notation for that. This is what I'm asking you to do. I want you to find all of them in. Oh, I can. But I want you to add them, subtract them, multiply them, and divide them to the best of your ability, and simplify, obviously. So take a minute, hit pause, try all four of those. We're going to try to do all four of those operations. Come back, and we will check your answers. Okay, we're back. I don't know if you did it or not, but I'm hoping you did, and we are moving forward with this. So I want to add the two functions together. It amounts to just combining like terms. We can combine the squared with the squared. We can combine the constants with the constants. Review. Hopefully we got that one. Okay. The next one, subtract them. This was on that common errors thing, that common error station we saw. When we do this minus sign, this subtraction sign is going to get distributed to both of those. So yes, it's x squared minus x squared, and those go away. There's no more x squared. But now we have a negative 4, and we're taking away a negative 9, minus a negative 9. Minus a negative, that's a double negative, that means plus. So we're really doing negative 4 plus 9, and it is. It's just 5. Awesome. How about multiplying them? When we multiply them together, we are going to FOIL or expand or double distribute. It just depends on what you learn, but it amounts to multiplying x squared times both of these, multiplying a negative 4 times both of these. 4 multiplication problems. And after you do that, you'll have some like terms. You clean them up to the best of your ability, and we're dancing. So that's as far as we can take it. We've multiplied the two functions together. Okay. How about the division one? That one looks like it could be tough, and sometimes it is, but in this instance, it isn't. Okay. When we're dividing, we want to try to cancel things out, cancel common factors. Remember, I cannot just cancel an x squared with an x squared. I hope you are not that person. That was on the common errors station. You're not allowed to do that. What we can cancel are factors. So I have to factor the top, difference of 2 squares, factor the bottom, difference of 2 squares. Now I can look and try to cancel anything I see. I don't see anything that's exactly the same on the top and bottom. So that's it. That is the answer to f of x divided by g of x, or f divided by g of x is how we would say that. Sometimes in the book you'll see this notation afterwards. It says x cannot equal 3 or negative 3. They're giving you a domain restriction. We talked about domain yesterday, hopefully. They're just telling you what numbers x cannot be. And obviously, if you put in a 3 or a negative 3, you would be dividing by 0, and the world would explode. Your calculator would start smoking, and it doesn't work. You cannot do that. So sometimes you'll see the books put that together. So that's what they're talking about. Awesome. Those are the 4 basic operations of functions. But as I alluded to earlier, that's not all there is. There's something called a composition of functions. And hopefully some of the bells and whistles are starting to go off in your brain like, wait, I think I remember this. I remember this from Algebra 2 or Algebra 1. A composition of functions. I start by going, we've heard of compositions in different disciplines. In music, we have compositions that we play. In chemistry, we have the composition of whatever this matter is, whatever we're looking at. In English, I think you have a composition. You'll write a composition. What do all of these have in common? And it's kind of going to be the same with the composition in math. The word composition, what we're talking about, what is something made from? What are all the little pieces that make up the matter? What are all the pieces of this written paper that you wrote for your English composition? It's the same way in math. What is something is composed from, composed of? That's what a composition is, and it's going to help us remember how we are going to do composition. Here's some notations we'll see. You probably won't see this one because it's confusing, but I have seen it in other books. You would think this is multiplication, but it isn't. This would be a composition, but our book does a good job and doesn't talk about that one. Our book will probably talk about this one, which is pretty familiar, pretty standard. You have this little tiny circle. It's not multiplication, it's an open circle, and we would pronounce this as f of g of x, f of g of x. Well, I find this one to be easier. We have f of 3. We did that yesterday. F of 10, then plug in the number. This just means in your f function, take out all the x's and plug in the g of x function. Plug in a whole nother function. One function made from another. It's composed of or composed from another function. Composition. Let's try some practice with this. Going back to, I think I talked about our vending machine model yesterday. A function is a vending machine. In this instance, the composition would be a vending machine inside of a vending machine. So I take my input, I plug it into the g of x function, and maybe it kicks out, I don't know, Skittles. Then the Skittles fall right into the f of x function, say, oh, Skittles, and then it will kick out something else. So it's a function within a function composition. That's what we're going for here. So here's our example problem. Here are two functions, f of x and g of x. I would like you to evaluate or figure out what, pretend like you couldn't see that. There you couldn't see that. F of g of 2. What is f of g of 2? Take a minute, hit pause, see if you can come up with it. All right, we're back. The hint here, when we're doing actual values like this, we're going to start with the innermost function. Remember my vending machine, we started by plugging the x, plugging our input into the g of x function. So that's what we're going to do here. I'm going to ignore this. I'm just going to figure out what g of 2 is. I'm not even going to use the f function. So I go up to the g function, I plug in a 2, I would get 5. So g of 2, just this little piece, is 5. So now I can replace that whole thing with a 5. Our new problem now becomes f of 5. I want to figure out what f of 5 is. So f of 5, we go to my f function, we plug in a 5, we would get negative 15 plus 5. And our final answer, what the vending machine, this double vending machine finally kicked out, is a negative 10. Excellent. Composition of functions. That's when we had actual numbers, actual input. But we can do that same problem a different way, and I may call upon you to do this. F of x and g of x, instead of actual numbers, I want you to find like a formula for the f of g of x function. So in this case, I don't have something to plug into the g of x function. I don't have a number to plug in here. I want to read this one as, I'm going to go to my f function, I'm going to take out all the x's, and I'm going to replace them with the entire g of x function. All right, so I'm going to come up here to my f of x function, take that x out, and replace it with a set of parentheses. In those parentheses goes the other function, 2x plus 1. And we can handle this. We can simplify this. We are experts, hopefully, distributive property and cleaning up. And we get a whole formula for f of g of x, negative 6x plus 2. Now let's take it back. That last note, I asked you to find f of g of 2. Well, we have a formula now that we could just plug in a single time, not have to do it in two separate steps. This formula has combined those steps for me and made this new function, this f of g function. So I'm going to plug in a 2, just like we did in the last one. I'm going to plug in a 2 into this one. I simplify it, and I get the exact same answer we got before, negative 10. One was taking it in pieces. One was getting a formula to find any one I want. If you're having to only do like one number, yeah, then probably taking it in pieces would be easier. If you're having to do a bunch and evaluate a bunch of these, it would make more sense to come up with a single formula that you can use over and over and over. Okay. Hit pause. Same two functions. Go back in your notes if you need to. I want you to now find g of f of x. We're flipping it around now. The f function is inside the g function. And then I want you to find g of f of 2. All right, you can use your formula you got here, plug in a 2, and see what it equals. We're back. There are the answers. Negative 6x plus 11. And then if you plugged in a 2 into that function, you would get kicked out a negative 1. All right, almost done here. I can only record so many minutes. We almost got it. Let's try with a table. Right, we learned yesterday, and I showed you guys when we were checking to see if it was a function or not. We were looking at tables, graphs, points. So those are all different relations that can be a function. And we have something like this. So I have my x's. These are my inputs. These are my outputs for the f function. These are my outputs for the g function. Why don't you try it? You didn't see anything. Why don't you try these three? See what you can come up with. F of 6. G of f of 0. F of g of 0. Or this one is g plus f